make the review video for 12.3. That's chapter 12, section 3. And the learning target for today is to find experimental and theoretical probabilities and use them to make predictions. So experimental and theoretical probabilities. Let's define those two terms. An experimental probability is an estimated probability based on the relative frequency of positive outcomes occurring during an experience. So this would be what we actually get when we do a probability in an experiment. And the next one here is theoretical probability, and theoretical probability is based on known characteristics or facts. So theoretical is what we would get in theory, and experimental is what we get when we actually do it. So let's jump right into one here. It says Nikki is conducting an experiment to find the probability of getting various results when 3 coins are tossed. The results of her experiment are given below. What is the theoretical probability of tossing all heads on the next turn? Well, if we look at the theoretical probability, there's a 1 out of 2 chance of getting the heads on the first flip, a 1 out of 2 chance on the second flip, and a 1 out of 2 chance on the third. So if I multiply those together, I get a 1 out of 8 chance of getting all heads. Now, if we look at the experimental probability, we can see that 6 out of 8 times, 6 out of, well, let's add up all of these that she got all heads, or so 6 plus 32 would be 38, that would be 68, 70, 80. So 6 out of 80 was the experimental probability. If I could reduce that, 6 would become 3 out of 4, 3/4, or 0.75 is the probability of getting, I'm sorry, I didn't do that division right. Let me recheck that division. That would become 3 out of 40 would be the probability of getting all heads on the next turn. So this is the theoretical probability and the experimental probability. All right. Marcus is conducting an experiment to find the probability of getting various results when 4 coins are tossed. The results of the experiment are given below. What is the theoretical probability of tossing all tails? Well, all tails would be 1 out of 2 for the first throw, 1 out of 2 for the second, 1 out of 2 for the third, and 1 out of 2 for the fourth. So 1 times 1 times 1 times 1 is 1, 2 times 2 is 4, times 2 is 8, times 2 is 16. So it'd be a 1 out of 16 on the next turn, 1 out of 16. If we look at here, if we're tossing all tails, that would be no heads. So there would be 5 times out of his theoretical data, which would be 5 plus 7 is 12. Plus 20 would be 32, plus 12 would be 44, plus 5, plus 6 would be 50. So we get 5 out of 50, or 1 out of 10 is our experimental probability. So 1 out of 16 and 1 out of 10. One's theoretical and one's experimental. Nikki is conducting an experiment to find the probability of getting various results when 3 coins are tossed. The results of the experiment are given below. According to the experimental probability, is Nikki more likely to get all heads or no heads on her next toss? And this time we're asked to use the experimental data. So all heads, she got 6 times, and no heads, she got 12 times. So she is twice as likely to get no heads according to the experimental data. So she is 12 out of, let's add this up, 12 plus 32 would be 42, that would be 74, that would be 80. So she got 12 out of 80 times, 12 out of 80 that she got no heads. In other words, they were all tails. 12 out of 80 can be reduced. Let me think. 4 can go in there. 4 can go in there 3 times. 4 can go into 80 20 times. So it's 3 out of 20 was the experimental probability. The theoretical probability of getting all heads or no heads should be the same. She's tossed it 3 times, so it'd be 1 out of 2 times 1 out of 2 times 1 out of 2, which is 1 out of 8 is the theoretical probability. Marcus conducted an experiment to find the probability of getting various results when 4 coins are tossed. The results of the experiment are given below. According to the experimental probability, Is the Marcus more likely to get all heads or no heads on his next test? Well, all heads he got 6 times, and that would be 6 out of 6 plus 12 is 18, plus 20 would be 38, plus 7 would be 45, plus 5 would be 50. 6 out of 50 times he got all heads, and then 5 out of 50 times he got no heads. So he's more likely to get all heads than he is no heads according to his experimental data. 800 adults were asked whether they were planning to stay at home for winter vacation. Of those surveyed, 560 said that they were. What is the experimental probability that an adult planned to stay at home for winter vacation? Well, there's 560 said they were out of 800. So if we do a little reducing here, 56 out of 80. 56 out of 80, I'm going to divide 8 into 56, and I'm going to get 7. And I'll do 8 into 80, so it's 7/10 of the people said that they were going to stay home. So a 7 out of 10 probability that they were staying home. And that's experimentally. 500 adults were asked whether they were planning to stay at home on New Year's Eve. Of those surveyed, 300 said that they were. What is the experimental probability that they were adult planned to stay home for New Year's Eve? So that's 300 out of the 500 that were asked. That's 3 out of 5 is the probability that they're going to stay home for New Year's Eve. Over the past 3 years, the probability that a school math team would win a meet is 3/5. 3 out of 5 times they won a meet. If the team would like to win 12 more meets in the next 3 years, how many meets should the team enter? Well, to win 12, they have to enter X, and I'm going to cross multiply here. So 3/5 is my ratio. That means the ratio here is going to be 3/5. I multiply, cross multiply. 5 times 12 is 60. 3 times X. Divide both sides by 3. Divide both sides by 3. X then would be equal to 20. So according to this, they should enter 20 meets if they want to win 12, if their probability remains the same. A speech and debate. Over the past 3 years, the probability the school speech and debate team would win a meet is 4 out of 5. Is this probability experimental or theoretical? It is experimental because it was collected over the actual events over the past 3 years. So it is experimental. Speech and debate. Over the past 3 years, the probability the school's in speech and debate team would win a meet is 4 out of 5. If that team wants to win 20 more meets in the next 3 years, so we say 4 out of 5 is the probability. They want to win 20 out of how many do they have to enter to meet that? All right, so I'm going to cross multiply. 5 times 20 is 100. 4 times X is 4X. Divide both sides by 4. X then would be equal to 25. They should enter 25 meets if they win 4 out of 5 of them and they want to win 20 in the next 3 years. Thank you.